Hello everybody, welcome to episode 2 of our Python journey. So today we'll be finished learning about the different types of data. We'll finish learning about lists, then learn about its cousin tuples, and then their cousin dictionaries, and then finish off with functions. So let's get started. So we already know about a few Python types. We have strings, we have integers. However, there is another type, and it's called a float, which is basically a decimal number. Now, floats don't really differ too much from integers. For example, I can still add and subtract them together without any errors popping up. It's just that floats are known as a decimal, so I can actually use a type command to figure out what is considered what type it is, and in this case, always have your manned parentheses, and see, it's a float, because even if it ends up being an integer, like this would be 31, it would still be a float. Okay, so now that we got that out of the way, there is one very important variable, and that's called a boolean. And booleans can take either true or false. So for example, if we say W is true, this can be especially useful in while loops, for example. So a lot of times we do while true, but in this we can do while W because W is true. And I guess we can print W is true. Now see, W is true, and so we always have while W is true, print W is true. Now if we turn it to make it false, well then if W is false, it will not satisfy this condition. You can even search for something being false by using the not command. So while not W, see, nothing happened. But then, so while not true or while false. So, for example, if we do while W is false, while false, we will keep getting false because W is false. Then if we make W true, well, it doesn't satisfy our condition anymore because it is true. Alright, so that we were just finishing up our data types. Now, last video we went like a bit over lists, but I didn't give a really good example or a good explanation. So let's set the record straight in this video. To name a list, just say the list name equal to brackets, and a list can be anything. It can be any type. It can be a multitude of integers. It can be even a boolean, now that we know what those are. A float. Anyway. Now, here's the thing. This, I'm going to be referring to an element's place value as the first element, second element, third element, fourth element, like that. Because that's their place value. Hello is the first element. But if I say element 0, I'm thinking about it from Python's perspective. It's like, this is element 0, this element here, this is element 1, this is element 2, this is element 3, and this is element 4. So I'm just trying to get that terminology straight so I don't confuse anything or say something wrong when I'm actually explaining this. Alright, so to access an element, you give the element name. So if we want to access the first element or element 0, you put 0. So if we print element 0, which is aka the first element, we print is hello. If we print element 4, aka the last element, we get true. Make sure that your list has the range to sustain this. For example, if I did element 18, which would be the 19th element, well, there's only 5, not 19, so we wouldn't have anything there, and that's why you get the error. One of the best ways actually to access the last element of a list is to, if you have no idea what the length of the list is to use the length command, or len, parentheses, and the name of the list. Now, would this work? Let's think about it. The length of the list says how long the list is, and we can see it's 5. But wait a minute, we're looking for the element number, and we start at element 0. So the highest number is element 4, not 5. So really, we have to subtract 1 to account for this, and that's how we get the last value. If we didn't, well, we'd be looking for element 5 when the list only goes up to element 4. And yes, we'd get our error. Alright, now there are a lot of nifty things you can do with lists. You can reassign what's in a list. For example, if I want element number 3, aka the 4th element, to now be 14.3 instead of 13.7, I do it. Now, let's take a comparison. If I print the list, which is just going to print the list. Now, if I print the list after I update it, notice the comparison. Now, the element 3, or our 4th element, went from 13.7 to 14.3. Okay, now you can also add things to your list by doing the append feature. List.append, and let's add this is appended. So for now, I print our list and see what happens. See, we appended this, or basically added something. Alright. Finally, we can remove stuff by just, typing remove. However, there's no element this is append in our list right here. So if I ran it, we would get an error. So I guess let me just add it. This is appended. And now if I remove it, see, we removed the this is append element. Alright. So that basically covers all the basics of lists that we'll be using for a long time. Now, tuples are basically the uncool cousin of lists. They're defined using parentheses instead of square brackets. And look, I'm going to make mine the same as the list, but you can see soon they will have different properties. Mainly in tuples, you cannot change elements after they've been defined indirectly. So for example, I can still print the tuple, and it may look normal in the beginning. But then notice if I were to do something like try to change a tuple's value. For example, you can still look up tuple element names, again using the square brackets. But if I wanted to change element to 0, the tuple, to 15 instead of hello, well, I can't do that. It does not support reassignment. I have to physically go into the tuple and be like, change this hello into what I want. You can't even add or subtract anything from your tuple. For example, if I want to append it, this should not be here. I can't do that. I cannot at all change a tuple. So I guess if you want it to be like more solidified so you can't accidentally destroy data. But yeah, I don't really see myself using tuples. Alright, but now for the most fun mapping system, dictionaries. Again, they're defined with a name, equal, then you use curly parentheses or curly braces. And I like doing enter like this so that it looks aesthetically pleasing and more organized, but it doesn't really matter. Now, what I'm going to type here is a key, which is kind of like the word in a dictionary. You search it up, and then I do a colon to separate the key and like the definition, or in this case, a value. So John Milkman, that's his name. So if I were to look up John in my dictionary, I would get Milkman. Then you use comma to separate that entry, and you move on to the next one. Age 15. No, not 15. 35. He's an adult. Job, he's a milkman. Comma. Kids, he has 0. Alright. So now I can print my dictionary. And there it is. Now I can access elements of or the keys of a dictionary if I know their names. So for example, I know age is a key in the dictionary, and I can get its value by, looking it up using, again, the square brackets. So I searched up the age and I got the value, 35. You can even get the values by doing like dict.keys, like the dictionary name, so dict.keys. And that should give me all the keys. John, age, job, kids. I can even do .type.values to get all the values. Milkman 35, milkman 0. Alright. So yeah, that's basically all of dictionaries. To add a new a dictionary, you can just be you can introduce a new key and be like dictionary, what would be a good one? Spouse. And then you set it equal to none, for example, none. So then if I set that in, see there's no error. If I print a dictionary now, it's going there. And now I've added spouse, none. You can delete an element, for example. I could be like delete the age key, for example. And now if I print my dictionary, there's no more age. It's just John, milkman, job, kids, and now spouse. Okay, so that ends off all our data types that we'll be using for a majority of this journey. And let's get into, I guess, the second most basic advanced concept of Python, functions. So to make a function, you just do def or define function name. So for example, let's make a function hello, and then we're going to do parentheses. We're going to do colon, enter. Functions will be indented, so that just adds to our list. If and else conditions will be indented, for and while loops will be indented, and functions will be indented. Alright, so the entire point of this function is to print hello. So we defined our function. Now, how do we use it? Well, that's calling our function. So just to call our function, we do hello. And for that, now we don't have to put anything here, so we'll get to that later. But now we're calling our function. So it's doing its job, printing hello. So print hello from a function. Hello from a function. So it's pretty basic on our regular level. Now, why do we have these parentheses? I guess just to define it as a function. But we already have a defined keyword here. What's the point? Well, a function can take in values that you give it, and then you do something with it. So, for example, what if I make the function adder, which is just going to add two numbers together? I do x, now I do a comma to show I separated the entries, x and y. Now inside, I'm just going to do print x plus y, and that's just all my function. Now, if I want to call my function, for example, adder, then I say, okay, 15 and 23. So basically, I'm setting my x to be 15 and my y to be 23, and I'm just adding them together. And as you can see, it adds it to get 38. So yeah, that's basically the main point of this. Now, why is it useful? Well, of course, the function is probably going to be a lot more advanced than this. You don't want all of your things happening in the main line of code. You want to kind of like throw it out to some function so that they can check and do something. So, for example, if I wanted the user to use the adder function, I could get input from it. So for example, x is equal to input, as you may have remembered from last episode. This is how you get input from user. What is the first number you want to add? Then I say y is equal to input. What is the second number you want to add? Now, again, remember that x and y are going to be strings. And we remember from last video, you can't use strings with integers. So we're just going to have to integerize x, integerize y. Sorry, we don't define the adder. We call the adder. And now, here we go. What is the first number you want to add? Before we run this, let's make this look more aesthetically pleasing. Punctuation can matter. So, question marks are spaces. Alright, what's the first number I want to add? 834. What is the second number I want to add? 765. And they add them together to get 1599. As you can see, it can be useful. I promise that functions will be more complicated than this. For example, if I want to make a calculator called subtractor, define subtractor x and y. Remember, it doesn't matter that the variables are the same. The function knows that these are called like local. They're local to the function. They will not have any effect out elsewhere, which is something we'll get to next video actually on local and global variables. But x minus y. Now, of course, we can't just randomly guess, oh, do we want to add or subtract? So that's why we can pair it with an if-else statement. Response equals input. Do you want to add or subtract? Alright. Now, what we can do, for example, is say that if response, remember double equal, is equal to add, I guess I'm also going to use a few new keywords. We can use and to say that if this condition here and some new condition that we have are both true, then follow along. But we don't want that. We do or, which means either this condition is true or this new condition is true, which is response equals add. We will learn that there is a better way to do this, mainly by converting everything to uppercase and lowercase, but this is another way. So now, this is just to account for the possibility of the user typing in all lowercase. Now, if response is equal to add, we can ask our two questions, and then we can call the adder function. Now, if our response is equal to subtract, notice I'm not actually using the else statement because, the user could type a lot more things than just add and subtract. It's not really limited to anything. So this will be our last example, but there is one more thing I'd want to show you guys, just so you can keep it in the back of your minds. So I'm going to basically have the same terminology. What is the initial number? And what is the number you would want to subtract? And then, and now of course we're not calling on the adder, we're calling on the subtract. Hopefully this works. I've never had more than one line of code work, and this just is for aesthetics. Alright, I want to add. First number I want to add 15, was the second number 789. Enter 804. Alright, the adder works. Go into adder subtract. Notice see, I can type capitalize, but I have that case assured of here, which is something you'd want to just make sure to have so that your code doesn't throw out random errors or give bad responses for something that could be avoided. But 987 is my initial number, and 154 is my new number, is the number I want to subtract. And I get 833, which is right, so it works. Now, of course, we could finish up all the calculator, but I'm a bit lazy, so I'm not going to do that. But there's just one more thing, which is you can't say the response of your function if you have a return command. So for example, I'm just going to bring back our adder one more time. X, Y, colon, enter. But instead of printing X and Y, I'm just going to return X plus Y. And that's basically saying whenever you call the function, if it's used in something, then it will, be returned in it. So if I print adder of 15 and 23, it's just gonna, the function is basically in these parentheses returning or giving this print command that X plus Y is going to be 38, and then you're just printing 38. This can be useful sometimes. I've never really had an explicit case where I need its use, but it could be useful for when you're trying to use a function's values and set another function's values. Like for example, if I wanted to do the adder of 15 and 23, if I want to add that sum up with 15,675, and I want to print that result. So let me just put this in our print. And now see, the 15 and 23 is getting returned into this part, so it will act like the X term, which we know is 38. 38 plus 1,567 is 1605, and we're printing that. Alright, so that's everything really about functions that we need to care about. A brief guideline for next video, we will be doing a dive into classes and objects. I don't know whether we will learn about inheritance, maybe scratch the surface of it, and polymorphism. But that's something for next video. Anyway, thank you guys for watching this. I hope you enjoyed this content, and I hope I can continue making these videos. I find it really enjoyable. Anyway, thank you for watching. Goodbye.